Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Kadisha Amira binti Zohisam. My student ID is 2020964183 and I am from AS2016A. Today I will present my final year project entitled Specific Leaf Area of Araceae species and its correlation to soil element. The abstract of the study. There is an abundance of different Araceae species as decorative plants at UiTM Jangka Pahang, and the correlation of leaf area, leaf mass, and quantity of heavy metal in soil of Araceae species is undetermined due to lack of research. The aim of the study is to investigate the interaction between specific leaf area (SLA) and heavy metal in soil from Araceae plants. 10 species of Araceae were found on study sites. The average of leaf area and leaf mass was calculated for SLA determination, and heavy metal elements were determined by soil analysis using ICP-OES. As for the result, positive correlation between SLA and heavy metal elements such as Cu and IPB, as the R value were negative 0.04, negative 0.371, and negative 0.018 for the 3 metal. And the amount of heavy metal can give effect to the development of plants. Thus, it is hoped that this preliminary study will provide baseline for the future investigation. As for the introduction, Araceae, or commonly known as Araceae, is belong to monocots flowering plant family, and common distinguishing feature is based on its spathe and spadix inflorescence. Specific leaf area (SLA) is used in many ecological or ergonomic processes such as photosynthesis, nutrient balance, stage of development, transpiration, and prediction of crop model leaf area from dry leaf weight or vice versa. Heavy metals such as CD, zinc, and nickel are necessary for the growth and maintenance of the plant, but too much of this metal can be hazardous to plants. Next, problem statement. There is abundance of different species at UiTM Jangka Pahang as decorative plant, and the correlation of leaf mass, leaf area, and quantity of heavy metal soil of Araceae species is undiscovered due to lack of study. Thus, the relationship between specific leaf area (SLA) and elements of heavy metal in soil also remain uninvestigated. These two relations can predict the soil fertility, since the nutrients in soil are important for the growth of plant species. The significance of this study are the awareness of SLA and soil characteristics of Araceae species will be recorded as new data and increase the growth of individual presence at UiTM Jangka Pahang. This study will provide preliminary information of one of leaf traits, which are leaf mass and leaf area for Araceae species, to reflect over the plant development. In addition, it is hoped that this study will provide baseline information for further environment monitoring and practices to conserve Araceae species. Hence, this will pave way for future investigation by the researcher. There is 3 objectives in the study. Firstly, to determine the specific leaf area of Araceae species. Secondly, to identify heavy metal in soil of Araceae species. And thirdly, to examine the relationship between SLA and heavy metal in soil of Araceae species. Next, I will explain on literature review. Firstly, analysis of Araceae at Malaysia. In Peninsular Malaysia, there is 140 species listed from 28 subfamilies, and 25 of them are endemic. Secondly, for SLA incorporate a relative relationship of leaf dry mass and leaf area, and it contributes significantly to the connection between the carbon and water cycle in plant, and it is frequently employed as input parameter in model of ecosystem activity. The last literature review was on soil analysis of heavy metal elements. Heavy metal in soil such as copper was high in East China, caused by copper mining. Soil heavy metal pollution can give effect to the plant growth and lower the crop yields as plant need it as nutrient. Moreover, the methodology in the study have three parts. First part is leaf area and mass, where I perform drying, weighing, and average. And then the second part is soil element, where the soil is being dry, crushing, sieving, and filtering. And lastly, the analysis is using ICP, OES, and IBM SPSS 27. As for the result and discussion, firstly, the highest SLA was 569.45 cm square and the lowest SLA was 192.3 cm square. Previous studies found that low SLA plants have longer leaf and investing more dry matter per leaf, and it is usually have low rates of relative growth and total rate of photosynthesis. Secondly, the presence of heavy metal in Cu in sample of soil was higher compared to other metal, which is CD and IPB and zinc. So, previous study also found that the photosynthetic and metabolic pathway in plant can be inhibited by high concentration of Cu, which cause low biomass and delaying fruiting and flowering of plant. Thirdly, the result was the correlation between SLA with CD, which is the R value is 0.087, and zinc, the value is 0.240, is not significant as the R value is more than 0.05. There is also other factor effect, the SLA, which is studies by Bohora, find that the correlation between SLA and the climate, as they found variety of climate show firmness of leaf as there is different weather or water condition. It is explained that firmness of leaf can be a result from the reduction of plant photosynthetic process and amount of carbon gain. So specific leaf area can be affected by many factors, such as in the study is soil and previous study is climate. As for the conclusion, there was positive and negative correlation of the species as the amount of heavy metal is quite low at the study sites. This is because the study site is mostly undisturbed area, landscape and cultivated area. But the presence of heavy metal element can be an indicator to other soil sample in other polluted areas. The recommendation from this study is by adding soil analysis based on psychochemical analysis such as soil pH and quantity of organic carbon. And second recommendation is calculate leaf for both fresh and dry leaf area, compare it with leaf mass to find better differences between correlation. That's all from me. Thank you for your time.